Hey, math tutor here. These are step-by-step solutions, and I'm going to show you how to exactly write your answers. So we need to figure out why this can't be the slope field. Well, the first thing I notice when I look at this slope field is all the lines are positive, like they have positive slope. I mean, these ones are pretty flat, but still, it's positive, right? So should they be positive? Well, this is negative, so I think as long as h is bigger than 20, then this differential equation should be positive, right? The derivative, the slope, should be positive. Okay, so these lines are like all wrong, right? We know that h is bigger than 20 here. I mean, all of these values are bigger than 20. So this is like all wrong. So that's what I said here in my answer. The slope should be negative. I even used a minus sign. You can do that. You don't have to write the word negative. But in the slope field, the slopes are positive. And that is literally how I would write my answer on the actual exam. Okay, so now on the part B, let's find the slope of the tangent line. Slope of the tangent line, I mean, that just means derivative, right? I mean, they wrote a lot of words here when they could have just written derivative. So, all right, interesting. But, okay, so it is at time t equals 0. Well, when t equals 0, it's 75. So I think I just need to plug in 75. So it's negative 11 over 3. But remember, you do not have to simplify on the FRQ section. So you could just leave your answer like that. And that's literally how I would write my answer. Wow, that's not a lot to write, but you could write your answer this way. Now in part C, okay, is it an underestimate or an overestimate? So first of all, they actually gave you the second derivative here, which is crazy. It can be shown that, yeah, you could show that this is the second derivative. You could take the derivative of the differential equation and you would get that, right? So they kind of like did part of the question for us, which sometimes they do that in these FRQs. I always think that's interesting. Okay, but so we have to figure out if it's underestimate or overestimate. The way it works is if the second derivative is positive, then you have an underestimate. If the second derivative is negative, then you have an overestimate. Okay, so t equals 5, right, 5, 5. So that means that h will be in between 20 and 75. It literally says that here, yeah, for t greater than 0. Cool. So as long as h is bigger than 20, yep, that means this is going to be positive, right? If h is bigger than 20. So second derivative is positive. That means underestimate. Right. And this is how I write my answer, which is literally the same exact sentence. Cool. Now in part D, separation of variables. There's always separation of variables on any differential equations FRQ. All right, so here's the differential equation. So first thing I would do is like, kind of pretend that that's a fraction dh dt and multiply both sides by dt because those will cancel. All right, so then what you're left with is dt on this side, dh on this side. So that means that like this is the h side. This is the t side. There's really no negotiating that, right? Like that's kind of just how the sides have to be. So that raises the question, what is this doing over there? Like that should not be on the right side. It needs to be on the h side. So we need to move that over. So you can like divide both sides by h minus 20. So that's like what I did. So now you have h minus 20 on the left side in the next line. And at this point, all the variables are separated, right? H's are together, T's are together. Well, there isn't really a T here, but Okay, so we are ready to integrate now. So we have to integrate both sides of the equation. So the left side, this is what the integral is equal to. A lot of people would do a u sub here. That's fine. Cool. If you want to do a u sub, you can compare your work to my work over here. But all right, and then the right side of the equation, you just add a t to it, right? Cool. And then you have to put a plus c somewhere. You don't have to put it on both sides of the equation, but so I put it on the right. All right, so at this point, what do we do now? So I need to get the value of c. I also need to solve for h at some point. Let's get the value of c first, I guess. So I plug in the point. This is a point they gave us, right? It comes from there. So you plug in that point into like h and t, and then you're able to solve for c. It's natural log of 55. Cool. So now I rewrite the equation, right? The equation I had here, I'm going to rewrite it. No longer will there be c in the equation. Now there's going to be natural log of 55. And I just need to get h by itself. So, this is just like algebra at this point, but you can like e both sides, if you know what I mean. Raise both sides to the power of e. And then add 20 to both sides, and there you go. That is your answer. Is there a way to simplify this more? Yeah, but you don't have to do it. Remember, no simplifying on the FRQ section. And this is how I would write my answer. I did it differently, actually. I solved for h first. See, I got h by itself first, then I plugged in the point to solve for c. So it looks different. I even got a different value of c technically, but it is fine. This is, an equivalent answer to that one. So both methods are okay. It doesn't really matter which one you do. One might be like marginally faster than the other, but it doesn't really matter. All right. Well, the official solutions to this FRQ are not available yet. I'm literally recording this on the day that they just released the FRQs. But when the official solutions are available, I'll post a link in the description so you can compare my solutions to the official ones. But yeah, that's it. Thanks for watching.